Salutations, mini mathematicians! Welcome back to Module 8. It sure is great dealing with transformations. So we've gone over a lot of different types of transformations, and now we're going to be looking at the relationships between the pre-image and the image after a transformation occurs. So we're really focusing on today is congruence, and I usually say it's like a cookie cutter, congruence, same size, same shape. So if I made a bunch of cookies all the same size and shape. This is the symbol for congruence. It looks like an equal sign with a little tilde on top. And our purpose is to be able to perform the given transformations, because more than one possibly, and justify if the resulting images are congruent to the pre-image. So let's get started. 8.1D lesson, congruence. In the previous examples, only one transformation was applied onto a figure. What happens when a sequence of transformation is applied onto a figure? So if you finished that extension from the previous lessons, you maybe performed multiple transformations, but this is the first time in a lesson. So we're going to examine, so this is our pre-image. So I'm going to look at this triangle ABC. Can't really see that, so we'll try it with this one. So we have triangle ABC as our pre-image, and the first thing they want us to do is reflect triangle ABC over the y-axis and label the image triangle A prime, B prime, C prime. So since this is the y-axis, I'm going to highlight the y-axis. And remember, when we reflect, we're equidistant. So taking a look, C is 1, 2 away from the y-axis, so we're going to go 2 over. Can also use our rule that we came up with, reflecting across the y-axis. XY is mapped to negative XY. So we can say B is at negative 1, 2, 3. So now we're going to be at positive 3, 1, 2, 3. B prime. A is at negative 6, 3. So now we're going to be at positive 6, 3. And maybe you use a straight edge to connect these. Make it look good, like it should. Gonna perform that reflection across the y-axis. Okay, so here we go. So now it says our next item that we're doing is we're going to reflect triangle A prime, B prime, C prime over the x-axis and label the image triangle A double prime, B double prime, C double prime. So I'm going to highlight my y-axis because that really, x-axis, I misspoke, the x-axis, because that really helps me visualize these. And we're going to have from XY, remember this rule because we're reflecting across the x-axis, xy goes to x, comma, opposite of what y was. So we'll have C double prime, B's at 4, so we're going to go to negative 4, 1, 2, 3, 4. B double prime, A's at 2, 3, so we're going to go down 1, 2, 3. A double prime. Beautiful job here. Okay. What one transformation is the same as this double reflection, and explain? So there's one transformation we can do to our pre-image triangle ABC to end up at our image A double prime, B double prime, C double prime. Do you think you know what it could be? If you are thinking a rotation, you are exactly correct. So if I take the origin and I look at where A, B, and C are, and I rotate, let's look at clockwise, 90 degrees, 180 degrees. Notice I end up exactly on my pre-image. And remember, since we're going 180 degrees, it doesn't matter if we go clockwise or counterclockwise, because halfway around the circle is still going to be halfway around the circle. So what one transformation is the same as this double reflection? 180 degree rotation clockwise or counterclockwise about the origin. If we explain, we can say pre-image and image are congruent and result in the other. So they result in each other after that. And I guess using the word congruent, I kind of jumped the gun because it said examine. What do you notice? Both triangles. So pre-image and image are the same size and shape. Corresponding so you can see a little better. Corresponding angles are the same measure. Corresponding side lengths are the same length. Hence, congruent figures. And remember, this is the symbol for congruent, cookie cutters. Cool, let's keep going. So now we have another pre-image and a list of transformations to apply. And what I'd like you to do is I would like you to work on 2 A through F on your own. So go ahead and pause the video now and work on number 2, and then we will go over it together. Okay, let's see how we did on number 2. So the first thing we had to do was reflect over the line x equals 1. Remember, the line x equals 1 is a vertical line where x equals 1. All the x values are always the same. So x equals 1. So from here, I'm going to go over 1, 2, 3, 4. So I have to go over 4 more. 1, 2, 3, 4 to get the E prime. Corresponding vertices are equidistant from the line of reflection. D, we can also think about it as if we have to go over 1, 2, 3, 4, 5, 6, 7. We have to go over 7 here. 1, 2, 3, 4, 5, 6, 7 to get the D prime. Can count what the slope is from E to F, and that'll be the same as E prime to F prime. We can also do is that since this is at -2 plus the 1 more, we're going to go 2 more plus the 1 more to get to F prime. Connect those, making it nice. Okay. Now, check that that. Make sure you have your nice labels. Now we're going to reflect our new image, triangle D prime, E prime, F prime over the y-axis and label the image triangle D double prime, E double prime, F double prime. So we're going across the y-axis. And the y-axis, remember, is actually the line x equals 0. So we're not going to end up back on here. We're going to actually end up, if you think about this, 1, 2, 3, 4, 5, we need to go 5 over 1, 2, 3, 4, 5 to get to E, oops, I'm using the same color, E double prime. So we're going to be translating really from E to E double prime to the left. Let's see if that holds true for D to D double prime. Well, from D prime to my line of reflection, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to need to go 8 over 1, 2, 3, 4, 5, 6, 7, 8. The same thing held true. I'm just translating 2 units to the left. Double prime. Let's see if I can freehand this, make it look okay. Not really nice. So we did that. What one transformation is the same as this double reflection above? Well, that one transformation of the double reflection, like we realized here, is just a translation two units left. And if you've been looking at mappings for these or coordinate rules, here we had xy went to negative x plus 2 comma y. Then we had xy, since we were just going across the y-axis, that's just changing the x value. And for this last one, do you have an idea of what that coordinate rule is going to be? A translation of 2 units left? Now it's going to take xy, and since you're only changing to the left, we're going to take 2 away from the x value and keep the y value. So that is your mapping. It's also called a coordinate rule or a mapping, not to be confused with a mapping like a relation with a function. Let's see, state the coordinates for the vertices for pre-image triangle DEF and image triangle D double prime, E double prime, F double prime. Well, DEF, if we take a looky at that one, we had, and you probably found this filling this in, negative 6, 3, negative 3, 4, and negative 2, 1. And double prime, we had negative 8, 3, negative 5, 4, and negative 4, 1. So we have here, oh, and then they wanted the coordinate rule, which we actually had already came up with above in orange. You're just being extra. X minus 2, comma y. So if we examine these two shapes, if we examine really all 3 of these shapes, what do you notice? They're all the same size and same shape, which means all 3 of these are congruent. The reason they're congruent is because we were performing only rigid transformations. We're not changing the shape or size at all of our image and pre-images. So, same size and shape. Hence, therefore, we can use these 3 dots that mean hence or therefore also. You can use the word hence. Congruent. Cool. Let's take a look at number 3. So we have quadrilateral QUAD. So cute. We're going to reflect across the x-axis to get our first image. So let's do that. And remember, if we are looking at coordinate rules here, xy, when we go across the x-axis, only changes the y value. So we're going to have Q prime U prime, A is at 1, 2, 3, 1, 2, 3, A prime, and D prime. Dun, 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 dun. Now we're going to take our image and use this rule. Notice what type of transformation this rule is. It's a translation. Translation is a slide or a glide left or right and or up and down. Here, since we are only affecting the x value, we're changing all the x values by 9. So we want to go to the right 9. So D prime to D double prime, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can also use some simple math. Q prime is at -6. -6 plus 9 is going to get you to 3. And you can always just count 1, 2, 3 to get to U. 1, 2, 3. Double prime. Notice we have still congruent figures. This is a rigid motion. Okay. Examine. What do you notice? Like I said, congruent figures. Congruent figures. Only rigid motions. Reflection and translation applied. So thinking about this, remember when we looked at reflections and rotations, we could have also gone from quadrilateral QUAD to quadrilateral Q double prime, U double prime, A double prime, D double prime by performing a rotation. So there's 3 types of rigid motions: reflections, translations, and rotations. Cool. Let's take a look at our next one. So taking a look at number 4, we're going to be examining a new quadrilateral, and we're going to describe how the 2 figures are the same. So we're going to use our best mathematical vocabulary to do this, looking at how these are the same. So describe how the 2 figures are the same. Well, first we should probably look at the corresponding segments and corresponding vertices. Well, corresponding segments in the pre-image and image are the same length. Making perimeter the same, making area the same. Corresponding angles have the same measure. Parallel sides in the pre-image preserves this relationship in the image. I guess we should say parallel sides in the pre-image are preserved in the image. Okay? Describe how the 2 figures are different. Well, how are they different? The orientation is different. Orientation in the coordinate plane. is different. So it makes it different. It's in a different location and it's oriented differently. So it's not just translated, slided, or glided right, left, up, and down. There's obviously some other type of reflection or rotation occurring here because it's orientated differently. What was up is now down. What was down is now up. So we need to think about one transformation or sequence of transformations that will carry preimage A, B, C, D onto image A prime, B prime, C, D prime. So what do you think? Go ahead, play around with it for a second. What do you think? What sequence or just one of them? Okay, well, maybe you notice that this can be a 180-degree rotation clockwise or counterclockwise. About the origin. If you noticed there was two transformations, and if you didn't notice there was two before, take a look and see how you could make this, how you could bring the pre-image to the image with two different transformations. What I saw was you could reflect across the x-axis, followed by a reflection across the y-axis. And one of the ways I saw that is by looking at corresponding vertices. If I looked at D, which is -4, 3, and I look at D prime, which is 4, -3, I'm noticing that my XY is now a -X, -Y, which is telling me I'm combining both of those reflections together. Pretty cool. Are the figures above congruent? Are they congruent? Are they like cookie cutters? Yes. And in fact, we're going to add to our notes a little bit more here. Any two-dimensional figure created by a rigid motion which includes rotation or more than one rotations, reflection or more than one reflection, and or a translation or more than one translation. So I should make it curly brackets. Created by rigid motion or sequence of rigid motions. Results in a congruent image of the pre-image. So that's a big hint if we were looking at what type of transformation was this. If we have something congruent, we know it could not be a dilation. We're not going to be changing the size. Cool. So let's do a little bit of reading. So if you can please follow along while I read to you. A translation, a reflection, and a rotation are rigid motions that preserve the dimension and shape of a pre-image. Meaning if before we are two dimensions, we're going to stay two dimensions. If one or more rigid transformations are performed on a preimage, the image created has the same size and shape as the preimage. The preimage and image are congruent figures. This is the symbol for congruent. Just remember, if it's a translation, a reflection, or a rotation, these are all called rigid motions. Two figures in the grid are congruent. This is written symbolically as triangle XYZ is congruent to triangle PRQ. The order in which the vertices is written tells us which segments and which angles are corresponding in the figures, meaning X corresponds with P, Y corresponds with R, and Z corresponds with Q. Examine image triangle XYZ and image triangle PRQ. Describe a transformation or sequence of transformations that carry triangle XYZ onto triangle PQR. So I always like to figure out which one am I starting with so I know what I'm dealing with. So I'm starting with this triangle XYZ. That's going to be my pre-image. And then we're ending up over at our image. So maybe I'll just put an I here for image, just to keep my brain focused. So sometimes what I like to do is think about what vertices are corresponding. So Z is the last one that corresponds with Q. X is the first one, and that corresponds with P. And Y, I'll give it 3, is the middle one that corresponds with R. Last one's left. Okay, so what could we do to get from one to the other? Well, I'm noticing that we're orientated a little differently. So we're not just going to do a translation. And I notice I'm going from quadrant 2 to quadrant 3. So a really quick way to move from quadrant 1 to quadrant 3 would be to reflect. And oftentimes using a piece of tracing paper can really help show this. So if I traced Y, Z, X. So if I just reflected, pretty nice. I notice, I probably should have put my dashes on there. Maybe if I even just put one dash here to see if it lines up. I'm noticing that I'm in the correct orientation now, the right rotation, if you will, where Z is corresponding with Q. I just now need to move to the right. How many units do you think I need to move to the right? Let's see. 1, 2, 3. Oh, very, very nice. So let's see. What transformation or sequence? I'm going to give a sequence. I'm going to reflect. We have to say which one we're reflecting. Reflect triangle XYZ over the x-axis. And then it's really important to use those connecting transition words. And then next we will, following we will, our next step will be, and then translate 3 units right. And thinking about this, what we can do is we could translate 3 units to the right first. 1, 2, 3. And then we can reflect across the x-axis. Annotate the diagram to show which parts are congruent. Oh, we already did that. Oh, we forgot the side lengths. So ZX, I'm going to put 1 dash there. Oh, actually, what I should do is the 1 dash should be across from the 1 arc. So X, Y is between 2 and 3. So 2 and 3 is also going to have 1 dash across from the 1 angle. That's how you're going to stay really organized. XZ, notice it's across from the 3 dash y. So across from the 3 dash y should be here. And PQ between 2 dashes and 1 dashes between, 3 dashes. Between 2 and 1. Oh yeah, between 2 and 1 is 3 dashes. And the last one, X, has 2 dashes, so it's going to be across from the 2 dash side. Angle P has 2 dashes across from the 2 dash side between 1 and 3, and this is between 1 and 3. So now our diagrams are annotated to see what parts are congruent, and that means angles and sides. And this is just a symbol for angles. Some people just use that symbol for angles. However, I think it looks too much like an inequality symbol. So to be as clear as possible with my communication, I oftentimes put an arc across that angle. So list all congruent corresponding parts and write a congruent statement. Well, let's start with the angles. And you can use the statement here if you want, or you can use the diagram. So using our diagram, we can say that angle X is congruent to angle P. Angle Z is congruent to angle Q. And the last one, angle Y, is congruent to angle R. So those are congruent angles, our statements for our angles. So now let's look at our corresponding side lengths. Segment XY is congruent to segment, so that's 2, 3, so 2, 3. Or we can look at which ones we dashed with a 1. PR, segment PR. Let's see, 2 was segment YZ, and YZ is congruent. The 2 here is on segment QR. And 3, segment XZ, can also call it ZX. XZ is congruent to segment PQ. And finally, we need our congruent statement. And our congruent statement is that triangle XYZ is congruent to triangle PRQ. X and P, Z and Q, Y and R. Perfect. Do both images have the same area? Well, they have the same size, which means yes, they have the same area. Yes, same size and shape. You say congruent, hence same area. So now we're just going to kind of condense and put some of our patterns that we've noticed into each of our transformations that we've been focusing on. So which of the following properties of a figure can change during a rigid motion? So translation, reflection, and or rotation. So let's focus on a translation first. The slope of a side. Would a translation, just translating left, right, up, and down, ever change the slope? No. Orientation, just going up, down, left, and right. Would that ever change the orientation, what's up and what's down on the shape? No, the top's going to stay the top, the bottom's going to stay the bottom. Side lengths. Will translation ever change the side length? No. Perimeter. Will a translation ever change the perimeter? No, because it's not changing the side lengths. And will it ever change the area? No, because it's not changing the perimeter because we're not changing the side lengths. So we are not going to talk about translations. Okay. Well, now let's talk about reflections. Slope of a side. Will a reflection change? Yes. Reflections. Okay. Orientation. Yes. When we reflect, it's kind of like a flip. So the up turns to the down turns into the up, in the upside down. Ooh. So reflections. Does a reflection change the side length? No, it makes congruent shapes. Will it change the perimeter? No. Will it change the area? No. And what about a rotation? Will a rotation change the slope of a side? Yes. Will it change the orientation? The up might be the down now, and the down might be the up? Yes. Will it change the side length, the perimeter of the area? No, because remember, we're not changing the size of the shape. So side lengths, no. Rigid motions create congruent figures with equal side lengths. Perimeter. Perimeter change? No. Rigid motions create congruent figures. If side lengths are preserved, that means it doesn't change. Perimeter can not be affected. Okay. An area, no. Rigid motions create congruent figures. Size does not change, hence area is preserved. How would you change the area if you can't change the size? That's what area is. It is a type of size. Awesome. So here we go, number 7. I'd like you to try number 7 on your own. So we're going to be using triangle ABC, and the diagram below is our pre-image. And then we're going to apply the following rule to determine whether the resulting image is congruent to our pre-image. And we're always using triangle ABC as our pre-image, and that's really important. So go ahead and pause the video and we'll go over it. Okay, let's see how we did. The first thing that we wanted to do is we are going to take x, y, z and bring this to negative x, positive y. Remember, this is a reflection across the y-axis. So since this is a reflection across the y-axis, C prime, 1, 2, 3, 1, 1, B prime, 2, 3, A prime. So hopefully your triangle looks very similar to mine. And is the resulting image congruent to triangle ABC? So maybe I have to say yes. This is a reflection across the y-axis, a rigid motion, and hence results in a congruent figure. And you can spell out the word congruent or use the symbol. Okay, let's look at the next one. xy goes to x minus 4, y minus 8. Is this going to produce a congruent figure? Remember, we always start from our original pre-image. So yes, this is a translation. And if we think about this, we're going minus 4 from x. X controls the horizontal directions. Translation left 4 units. And down, y controls the vertical direction up and down. Down 8 units. this is a rigid motion. This is when I went copy and paste with my eyeballs, you guys. This is a rigid motion, and hence results in a congruent, ooh, can we say image? Ooh, I like that, using good math vocabulary. Okay, so let's perform this from our original one. We are going to go down 4, 1, oops, sorry. Don't go down 4, go down 8. Go left 4, 1, 2, 3, 4, and down 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to call this B double prime just because I already have a B prime and that would get confusing later. So left 4, 1, 2, 3, 4, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And slide and translate. Yeah. Okay. A, left 4, 1, 2, 3, 4, down 8. 1 and 2 and 3 and 4, 5, 6, 7, 8. Oh, my B prime's getting in the way of my A double prime. Bust a move. Let's just make this B prime show up a little bit. Okay. And then we had our last one, which xy went to 2x comma 2y. Well, maybe for this one you wanted to make a little bit of a table. So if we looked at A, B, and C, A is at -6, 3. B is at 1, 2, 3, -3, 4, and C is at -2, 1. And notice what we're going to, so this is our xy, and we're going to 2x comma 2y. We're multiplying our original vertices. This is not something that is showing a translation. It's not showing a reflection. It's not showing a rotation. Let's look and see what this gives us. So -12, 6, -6, 8, and -4, 2 for A triple prime, B triple prime, and C triple prime, respectively. So -12, so that's why this coordinate plane is so big. 10, 11, 12, up 6, 1, 2, 3, 4, 5, 6. A triple prime, -6, 8. B triple prime, and C -4, 2. C triple prime. My goodness, what happened to our triangle? Our triangle got bigger. So is it like a cookie cutter, the same size and shape? No. It's the same shape, it's still a triangle, but it's not the same size. It's twice as big. So let's see. No. Did the resulting image congruent to triangle ABC? No. This is not a rigid motion. The pre-image is being stretched. Horizontally and vertically. The resulting image has corresponding side lengths that are twice as long. hence not congruent. Perfect. So hopefully you enjoyed those transformations. I appreciate all your hard work. You're doing such a wonderful job. I hope you're having a great day. Do your best. Be nice to everyone, and I'll see you next time. Video bar out.